G'day everybody and welcome back to the channel. I'm going to get the resistors laid out today on this board and probably a lot of other things as well. We'll see how I go. I wanted to get some of the work on camera, so we'll just see how much time that takes up. So I'm going to get started with these 2.2Ks. These, I'll go over why I've made the choices I've made. So these ones, because they're on the input pair, they're in a sensitive area of the circuit that's susceptible to noise. So I've gone with the metal film ones because there's less Johnson noise, current noise, whatever you want to call it. Basically, what I've done is areas where it's high impedance, susceptible to noise, I've gone with the metal films. Also areas that I don't want any inductance in, I've put carbon films there. Other areas where it's like power rails and stuff like that, if it's a really low value resistor and I'm not worried about inductance because the value is quite low, I will go with carbon film, I think. I can't even remember. I'm just gonna I've done days and days of reading about all the different theories people have and research that people have done on resistors, and I chose them all very carefully. So yeah, it'll probably make more sense as I go along and do it. Anyway, what I'm going to do is I'm going to bend the legs up ready and start installing the resistors. Just got to work out which way they go, because I can't remember if I stood them up on end or if I had them horizontally. Looks like I stood them up on end, because those are pads for resistors and the spacing is quite small. Alright, up on end it is. I'll start by cutting the short end. Should have just bent them by hand. Definitely would have been quicker. Alright. Actually, I'll just cut all that off so I have the lead. Yeah, this is definitely better by hand. Don't know what I was thinking there. So that's basically what I want, like so. And what I'm going to do with them, I can never work good when I'm on camera. When I do this crap on my own, 2 seconds, finished. Well, the first resistor is installed. Might just make a bit more space for myself. Yeah, that's better. Continuing on. I don't know if anyone enjoys watching people build stuff, but I thought maybe, I don't know, people might want something to watch to fall asleep to or something like that, you know, or just something to play in the background whilst they're doing something else, you know. This is probably a good video for that. Guess it depends what you like watching. I'm so eager to get this thing up and running. I'll tell you what I'm really eager for is to get that Quant Asylum, because I want to do some serious work on this, you know. I want to compare all different types of components, especially transistors in there for performance. You know, I want to add regulation to the driver circuitry. I want to add some other bits of circuitry to it. I wanted to keep developing this until I've got something amazing, and you know, it might end up even being one of my first products, because two things that I've always wanted to do is repair stuff and make stuff, and I've had a real struggle in later years trying to decide which of the two I want to do. I know it's one of them, and I've always wanted to build stuff, so I think I'm going to go with that. I just don't see the repair thing working too good for me. I'm not too sure. I wouldn't mind. That's the thing. I like working on older stuff. I just don't like working on new stuff. So I might, you know, start some sort of business where I build audio equipment and sell it. But I might also offer, you know, vintage audio repairs or something like that. Audio, video and TV, that sort of stuff. But for vintage, you know, I don't know. But I'm trying to work out what I want to do, because I'm trying to get something going for my life in this field. All right, that's the 2.2Ks on one board. Am I on camera? Yes, okay, cool. I find I have a problem with being conscious of stuff for some time, like, am I on camera, am I not on camera, is the focus locked? And then I think I'm used to it, so I stop paying attention to, is the focus locked, am I on screen, all that sort of stuff. And then I find that I'm starting to do a bad job in my videos again. So I have to keep on top of myself there, especially for you guys. This does take more time than just putting components through holes. I could crop the leads and just fold them over and, you know, solder them straight down to the board, but what the hell? You know, there wouldn't be too much surface area that way in terms of the component leg bonding to the copper pad, and I just don't like that. All right. These are the resistors that go between the NPN and PNP in the complementary feedback input pair. I was going to use a 1K resistor here, but according to Doug Self, a 2.2K resistor yields the best result. That's running at a specific current, which was 5.5 milliamps. I'm at 4 or 6 milliamps. One of the two, or maybe I'm at 5.5. I'm very close to that. So I did put a 1K in and then I changed it back to a 2.2K. Obviously, when the amp's up and running, there's all different things like these 2.2K resistors, you know, different transistor types, different capacitor types, different compensation network arrangements, you know. There's so many different things to experiment with and test. So we'll just have to see. But I mean, I'm trying to do it good so that even the first build is still going to yield an amp that's got, you know, really low THD and good performance, all that sort of thing. I don't want it to be a crappy amp. I don't want problems. I only want... Well, my camera just overheated, so it stopped recording all of a sudden, but I got those resistors finished, and I've also installed these 47 ohm emitter resistors at the top. So I think now I'll sort out the bottom resistors and the offset control. Offset adjust. Alright, I'm going to get these 68 ohm resistors in the bottom now. These are again carbon film. Basically, another rule that I've made for the resistors is if it's under a kilo ohm and I'm not worried about inductance, then it's metal film. Sorry, I worded that wrong. If it's under a kilo ohm and I'm worried about noise, it'll be metal film. If it's, no, oh my God. See, this is the annoying thing. I've made so many different criteria. Okay, so anything that's got a lot of current going through it, obviously inductance is going to be a problem, right? So resistors that have got more current going through them, I've gone for carbon film. But if it's in an area that it's susceptible to noise, I've gone for metal film, right? Then I've also got other little rules that I've added to that, such as like, you know, if it's under a kilo ohm, what was it? I can't think. I'm getting confused myself. I think I made a rule and said if it's if I chose it to be like a metal film or carbon film resistor and it was under a K, I wasn't going to worry about it so much, but I would try and use carbon film I can't remember. Yeah, it's a tricky subject because sometimes you can sort of want to go with the carbon film for one reason and want the metal film for the other reason. But on the whole, basically, like I said, areas that have got current going through them, if I'm worried about inductance in those areas, I've used carbon film. And the other thing, if it's like a really small value resistor, like 10 ohms or something like that, I'm not worried about it being in an area that's got current on it, even if it inductance is a worry, Like, for example, the resistors on the power rails. I wouldn't take that as far as the resistor in the Zobel network. There are some things, but that's because that's got audio frequency across it and full power, so that's a bit different. The resistors on the power rail here just have DC that's fluctuating a little bit with the load of the amp and, powering, for all intensive purposes, a capacitor that the input stage is drinking off of. So it's a little bit different there, you know what I mean? You've got to think, when you're designing something, you've got to really think about how the circuit is working in that particular part and what's going on, if that kind of makes sense. The other thing that I did research on was other resistor types. So you've got not just metal film, but I think it might be metal composite, like carbon composite. But I did research on at least 4 different types. I think it was 4 different types, maybe 5. And the composite types are no good. They're way worse than these types. Probably not for inductance, So actually, I should probably look into that. When I go to, actually launch a company and make ridiculous high-end amps, then I'll probably worry about that a little bit more than what I am now. I mean, I'm already worrying about component choice here quite a lot, But I'm not spending a ridiculous amount of money on components. I mean, I'm not using cheap shit, All these transistors are brand name parts. Not the cheaper end of parts either. Same thing with a lot of the other components, capacitors, even electrolytics. Those Weimar caps, they cost a bit of money too. Yeah, there is a bit of money going into this, but in the grand scheme of things, in the high-end audio file business, whatever you want to call it, yeah, this will end up getting taken a lot further, which is what I mean when I say I have other things to add to this, not just speaker protection and stuff like that, but, like voltage regulation for the front end and, yeah, a lot of different things like that, even better quality parts. I've already ordered 2 other things that I haven't mentioned. I mentioned in the last video some things that I've got coming for it, but I've found something else that I liked the look of, so I grabbed it as well. So I'll have to go get the capacitor banks to show you what I'm talking about. On these cap banks, I've got these 1 microfarad MKT caps. I found MKT caps that are made with a copper foil and copper legs. So I've got some of those coming. The other thing I found was a capacitor that's just a little bit bigger than this. Now remember, my concern with this cap is it goes here, specifically between any one of those 3 pads on each side. It could sit there, there, or there. And there's 2 of them. Now, just for referencing, Sorry if this takes a second. They sort of get jammed in the drawer because I've got too many in the one drawer. But these were my choices of MKP, quality MKP caps. Now, obviously these are too big, so I went with MKS4. It is not as good as an MKP, but it is way better than an MKT or just a Mylar cap or something like that. So I went looking again to see what I could find, and I found something. I found these caps that are called EPCOS, the MKP, and the like X2 sort of caps, Y1 X2 caps. And guess what? The MKP, they're 250 volt, and they look pretty small. They look like they're in between the size of that yellow cap I just showed you and the red MKS cap that I've currently got. So if, you know, they are as big as what I think they are, I'm going to use them instead in the buyers network. I only ordered 4 of them because I don't want to, I've already wasted my money buying these other ones in bigger amounts because I thought they were going to be the right size and they turned out to be way too big. So I only ordered 4 of them. The other thing I've only ordered 4 of is input caps. I've found, I think they're Nichicon Muse or something like that. Maybe Muse is a different company. They might have been Rubicon caps I got. They might not be the Muse series. They could be something else. But I got some very nice audio bipolar caps, but they're 25 volt 100 microfarad. So they should be a lot smaller than these. But I want to do testing on them and see how their parameters hold up compared to these big 100 volt ones, especially dissipation factor, ESR, stuff like that. And if these test better than these smaller ones, then these will be staying in here, you know. So yeah, there's going to be so much more stuff happening to this amp over the next few months. It's basically, you know, my goal a couple of years ago was to build something really powerful that's also high quality at the same time, which is just, you know, it's not something you see quite a lot. You find high quality amps that are fairly low powered outputs, and then you get high power that's nothing special, you know. I'm not saying they don't exist, but they're very expensive, and my goal is to basically release something, a line of equipment that's audiophile quality and you know, like high end, but not you know, not sell it for nothing, but you know, I want to sell at least half the price other people are selling their stuff, you know. Like, I just think 80 grand for an amp is, you know, insane. I've seen amps for $120,000, you know. Macintosh models between 50 and 80k, for example. It's just insane. I'm not saying they're not nice amps, but I just feel like that's robbery, and people should be able to buy something that's made nicely, you know, without having to spend that much money. So my goal is to do what I'm doing, build a really nice design, and then just spend months working on it, researching, you know, different parts and things to get the performance up even more, and, you know, just take it from there. Basically, I want to do other things too, like equalizers, crossovers, speakers, you know, all the other bits and pieces. So yeah. So you can think of these next few amps I'm going to be building as sort of test gear evaluation amps. I don't know how to explain it, but like this amp, I'll tell you something that really annoys me is the fact that well, 2 things actually. The way I did the output boards, because it's really hard to get the transistors off, and the heatsink being all threaded and having screws and nuts going through half the transistors, because I want to be able to swap parts in and out quickly and easily. So I'm actually thinking about what I can do about that. Don't be surprised if I end up buying 2 new heat sinks like those and making a completely different mounting scheme so that I can, you know, pull parts in and take parts in and out at ease for testing. The same thing with the boards. I'm really considering getting, I'm either going to do it with this amp, or I'm going to build an amp that's the same layout and make everything from output to input, input to output easy to change. All the smaller devices like these all being sockets, so you can literally just unplug and plug in, you know, because I want to do a lot of testing, and it's going to be bloody annoying trying to solder stuff in and out all the time, you know, just to take a test. Say I've got, I don't know, 20 different input pairs that I want to try, all different transistors. Could you imagine trying to solder 20 pairs of transistors, hitting test, desolder, solder another one, test? You got to do that 40 times or what? Yeah, no thank you. So yeah, there's going to be some interesting audio stuff coming up. And the other thing is, I'm not just doing this because I want to start a company. I'm also doing it because I love having a big system, and I haven't had one for a while. So I need to start sorting out speakers again. I've got drivers, I've got a couple of subs I've got to rebuild. Can't tell if I did half of these. Anyway, I've got some speakers that I've finished, some that are on the go, like projects that aren't finished, and some that I've just got the drivers. And timber, I haven't even built the boxes yet. So yeah, I've got a lot of stuff coming up to build. The problem is I also have a lot of stuff planned for in here in the lab, and doing all of this, as you can tell, takes up all my time, and I'm not getting anything else done, like my power supply that I'm designing. You know, I do really want to get that finished. I want to get my curve tracer finished as well. I've actually got two big projects that I'm already in the middle of. A really high precision low noise power supply and a full proper curve tracer that supplies voltage and current. And, you know, if I spend too much time doing this, I won't get that done. But yeah, this is kind of important to me too, so I'm just going to have to do the best I can do. And then I'm also trying to do other things, like, you know, like the data sheet, the breadboard series, just a lot of other random things that I'm trying to find the time for to fit in between. So yeah, I'm going to be pretty busy. But that's good, because there'll be lots of videos. The more busy I am, the more videos there are. Alright, the last 268 ohms. Well, for this input pair current mirror. Go where I want you to go. That will do. These are 2SC 3790s and their counterpart. They're copper legs. All the transistors are copper legs. They're all proper transistors. The legs are so thick for a TO 220p or whatever you call it. That I'm not. You can't make this up. I mean, I had to put a bit of force on that to make that twist, and that's already twisted. That's how freaking strong they are. I love them. I love them. That is wonderful. That is so solid. I mean, seriously, of all the transistors I've ever played with, these have got to be the strongest legs I've ever encountered. I mean, they're stronger than the legs on the output devices. They're thicker. I mean, they're not as wide, but they are fairly wide, but they are literally so thick. They're at least 1 millimeter thick. I'm not exaggerating. I'm telling you, that's literally a millimeter thick. It's just amazing. Could be 0.9, but I mean, it wouldn't be less than that. Anyway, that is the 47s and 68s fitted to the input pair and the current mirrors. So, oh, I just spotted something else. Oh, the pots, yeah. So I was having a think about that. I've put these provisionments here to put offset pots. But due to the fact that I've matched literally everything in the whole amplifier down to a few devices, like the drivers are off by 20, but once they're in the milliamp range, they're only off by 10. Everything's pretty well matched, and the input stage is perfectly matched. So I don't think I'm going to have offset issues. So I'm going to leave the pots off for now, but you know, the provisions are there, so if it's a problem, I can just add pots. I could also just tweak the value of the resistor. I mean, they're only 5% resistors. I could quite easily, you know, go through a row of resistors and, you know, go up and down by half an ohm or whatever and get it right. I probably will end up doing that once I've done all the experimentation and testing and added all the rest of bits of circuitry that I want to add to it. I will do that, but for now, you know, if it's plus 4 millivolts or something like that, I really don't care. I worry about making it perfect zero at the end. You know, there are people out there that don't care if it's 50 or 100 millivolts. I think they're crazy and should be shot in the foot, but you know, yeah. So other people say 20. I like it to be a couple of millivolts or zero, but that's me. So, well, I like it to be zero. Anyways, it's time to get the next resistors on here. So, I think what I'm going to do, I'm going to try and work out this compensation network, because I'm not going to lie, in the time that I laid this board out to now, I can remember everything on here like the back of my hand, except for not even this bit here. This, I know what's happening here, but just this bit here, I had to sort of cram a lot of components into a small little space I had left here, and in order to not have to put jumpers and stuff like that, and also have everything laid out properly current flow wise, I had to do a bit of MacGyvery to fit everything there. And the problem is, it's quite easy to solder a component, you know, between, you know, that pad and that pad, or 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 that and that, you know. I can really come a gut to there. So I think I'm going to try and work that out first. What I'll do is I'll put the two polystyrene capacitors in the feedback network first, because the thing is with this sort of stuff, once you start building the circuit, this is why I put the transistors on first, because once they're there, I can see which leg's the base, which is the emitter, which is the collector. Then I know what's going around that, if that sort of makes sense, you know. So by laying the transistors out everywhere, then I can sort of fill it in back from the transistors, you know. Say I know, you know, my current mirrors have got 68 ohm emitter resistors, so I've just put them in. You know what I'm saying. That's the method to my madness. Now you see why I got all my parts ready in the bag. So it makes it so much easier come today, building day. It's all just there ready for me. So we want the 470s and the 47s. I matched all these. They're all within a picofarad, some half a picofarad. Which again isn't, you know, the highest tolerance in the world, but it's pretty good. there are some of you watching that will probably be like, yeah, mate, that really doesn't matter. And there'll be other people that are willing to pay, 50 grand for an amp, and 0.1 of a picofarad matters to those people. I am trying to make, this appeal to everyone. So I want everything done to the best of its ability. All right. Which one's the 470 and which one's the 47? So 470 is the first one. Oh yes, that's on coming off the output of the, yep, okay. 470 is the first one. So that's these guys. And these are copper legs, not steel. So that's nice. I think everything going on this board has got copper legs. The only components I've got that have steel legs are, I think, those Chongx 47 mica caps, those MKTs on the cap bank. These capacitors have unfortunately got steel legs, but they're probably going to get changed really soon. And the 10 nanofarad capacitors that I have put across the diode bridge, the snubbers, they've got steel legs. Just trying to think what else. That's it. Everything else is copper. I'll tell you, I've spent a serious amount of time going through my parts and ordering shit and going through data sheets and testing stuff for this. Like, I'm really trying to do the best that can be done here. So let's hope it comes out good. I think I'm going to stand those up. Yeah. Yeah. The thing with standing components up on the end is that you end up with a longer lead length. But these are just too long, unfortunately. I do have 470 picofarad in a different form factor, but all the other ones I have are in this form factor, the values I need for this build. And the other thing is the 470 picofarads that I've got that are axial, they are, steel legs. So I don't want to use them in here. That's why I never threw them in the bag, even though I already had the 470 picofarads that I had. I wanted to wait until these came and make sure that these actually had copper legs. And they did. And I just want to point something out. It's not just copper legs doesn't just affect you in terms of ferromagnetic resonance, but the other thing is steel is more inductive than a little piece of copper, I believe. So you get a couple of things working against you when you use steel. Honestly, I'm sure it doesn't make that much of a difference in the audio band, but again, when people are paying top dollar for amps, they want top components. And you know what? I can't argue there. If I was to hand you $50,000 for something, you better damn well put proper components in it with copper legs, otherwise I'm going to come back and smack you. You know what I mean? You can't rob someone. You got to do the right thing. So, yeah. You know what? I didn't think about that. You can actually tell which is the outer foil with these caps. Oh, no, you can't. can you? Yeah, it's kind of hard to tell. I don't know why they don't put the center lead just coming straight out the center. Oh well, who cares? Again, you know, when I go to build an amp and charge some really high price for it, yeah, I will be paying attention to stuff like that, but it'll be alright for this. It'll live. So bent that lead the wrong way. These capacitor leads are really thin, like really thin. I'm not complaining because they're copper, although they are going to be more inductive being thinner. Honestly, that can be solved with board layout, because you could have the leads as short as that little elbow there if you laid the board out, or if I laid the board out a bit differently. So revision 2. Oh, you can bet your bottom dollar there will be revision 2. I'm going to have to take a break in a minute. I'm feeling sick in the stomach. I don't know why. I mean, I gather it's what I ate, but I don't know why I'm feeling sick. I do not feel comfortable right now. It's a bit tight. Sorry guys, cats are climbing up on things, jumping on things. Right, I'm not happy with the clearance on this. There's not really a lot I can do. I think I'll just leave it. Try and put a little bit more solder there. Alright, now I'm happy with it. Trust me, I know the bit overhanging doesn't make a difference. I'm just trying to make everything neat. So that's the 2470s. So now I'll put, just do one board at a time for now. I'll put the 247s on. Hate it when I don't get a bend right the first time and I have to redo it. Although that is the beauty of having copper. See, copper you can bend quite a few times before it starts to become soft. Steel component legs are certainly nowhere near as good as copper for that. Yeah, these capacitors are a little bit of a squeeze, but it's alright. Standing up they fit. I got a question. I don't know if anyone watching the video is going to have an answer for this, but if you do, can you leave it down in the comments? I might end up finding the answer out myself. I haven't looked yet, so I will just put that out there. But there's a company called Linear X Systems. I'm not sure what else they do, but I know one thing they do is they have a bit of hardware that I don't know if they are still making stuff, but I was reading someone talking about an older one on a forum that's an ISA card, so obviously older. But anyway, what it is, it's a bit of kit that works with a computer and some software and analyzes the properties of speakers when you're designing a speaker itself. And I'm not talking about the box and the crossover, I'm talking about the actual driver. It's called Linear Systems LMS, I think it is. Don't quote me on that, but I think it's LMS. Anyway, my question is, if anyone knows where to get one of those setups from, like even an old, fairly old used one, please either email me or let me know in the comments section, preferably via email so other people don't see it and buy it if it's the only one, because I want it. But yeah, I'm really looking for that too, because something I haven't mentioned to you guys that I've been doing since literally being a little kid is fixing and building speakers. You know, I will repair ripped cones, ripped surrounds, the tinsel leads, change voice coils, all sorts of stuff. I've swapped new different cones with different motors, assemblies, and made custom drivers, subwoofers. Yeah, I'm very big on that, so I'm quite interested in that setup as well. So if anyone knows, leave it down in the comment section. Or like I said, if you know where there's just one for sale, email me so I can go buy it without someone else going, oh, cool, I'm buying it. Not trying to sound like a, what do you call it? I'm not trying to be rude, I'm just saying, I mean, if there's only one and I'm looking for it, it wouldn't be good if you put it in the comment section and someone saw it there and bought it, would it? But I mean, if they're just on eBay or something like that, yeah, leave it in the comment section. These flush cutters are getting buggered up, but it's all good because I've got a new pair behind me. And it's not the same pair. We're going to be trialing a cheap $2 pair from AliExpress. And I'm actually quite curious to see how long it lasts, because two things I've noticed about those Duratech cutters I got from Jaycar is, one, if you actually put a little bit too much force on them, they actually break. The metal's like a sort of like a cast, I don't know what you call it. It just shatters. The other thing is, surprisingly, even though it's such a hard metal, it's also really soft. I mean, I just cut copper. Yeah, I do cut some of those little steel leads too, but they're very small. And these blades get buggered up in no time at all. And I mean no time. Trust me, I'm not complaining about stuff that wearing out. You know, no, it's supposed to wear out. The problem is it wears out way too quick. So we're going to take a look at these. I got these off AliExpress. They've got the angle on them, so they are flush cutters. Justin Lau, model 170. Use safety glasses. So it says max diameter 1mm copper wire. These, I've never noticed anything about that, but I haven't read the packet. Maybe it says that on the packet. I don't think it does, however. I've got no problem with the products being weak or not, being able to cut through, say, 2mm of wire if it says it can't do it. But if it doesn't say, I would expect it to cut through something that small. So we'll see how they hold up. Something else I've been thinking about now too, like I showed in the last video, I am not sure that even my output devices are real, not 100% sure anyway. I'm pretty sure, but just the fact that one of the onsemi logos has got a circle around it and the other one's got the circle made up out of 4 pieces, I find that suspicious. And my drivers, I pulled them apart and I've shown you guys how big the dies are in them. And I've got the fakes here right next to the real ones I got. And here's the problem. If I showed you them from behind, apart from just that little thing there, you'd think they're the same thing. Look, I don't think they are fake at all. They do have totally different legs. They're nice and clean. As you can see, the back's different to all those fake ones that have the same back. And, the typing and ink and everything is slightly different on it too. They do have, oh my God, my focus wasn't locked. They do have an actual brand logo on them and all the writings there. So, I pulled them apart. The die's huge inside them. It's not huge. It's the size it should be. I forget exactly what it is, but it's like 3mm or something square. Anyway, those are what I'm using as drivers. I don't know 100% how good they are compared to the real ones or like onsemi ones. And like I said, I'm not sure about my outputs. So, there's a good chance that I'm going to end up changing all the transistors in this thing again in the near future. I'm not going to do it straight away. I want to, run it, use it, do all the tests on it, see how low I can get the THD, and a few other things. But yeah, it's something I do want to look into. I'm not worried about them having any trouble dissipating their power or anything like that. Like I said, I've had a look at them and the die sizes are exactly the size that they should be. The quality of the constructions, it's bang on. There's nothing wrong with it. So it would purely be a quality issue, not let out the magic smoke issue, if there is an issue at all. Just had to make sure I was holding the right capacitor for a sec. Not a lot of space for that. No, I'm not happy with that. Try that. Bit better. It's just very hard to fit these. There's really not the space for them. Well, it's on. Alright, so I've got these 247 picofarad caps to fit now. I will say, whilst they are a tight fit getting them in there, there is no risk of them shorting or something like that. The leads aren't, close to touching or anything like that. It's just hard to actually get them to line up with the pads. I always forget to tin my pad. Alright, one more of these. There's still another 4 to fit in total, but actually, yeah, I will be fitting the other 4 in a sec because they are part of this network. There's some high frequency bypassing in the feedback network. Actually, I need to do a quick calculation on something. I'm going to have to stop recording because I need my phone. Alright, my apologies for not having the focus locked before. I just checked something and I was calculating the frequency for an RC network that's in the feedback network. I put 10k resistors in here to go with the 22 picofarad caps, but in actuality I need 15k. It doesn't have to be 15k, it could be another value, but 15k will work fine, so I'm just going to use 15k. So looks like I chose metal film for it. I should have. Yep. Now you can see why I've been keeping these in the bag as well. It can get quite messy quite quick. Alright, I'm going to put those away and I'm going to get some 15k in metal film. Alright, I've got 4 15k resistors here now. So, yes. Okay, we've got a 560 ohm to worry about before these. Let's work out where that goes. I'm worried about where I put things because the cats just randomly grab piles of resistors and stuff and run off with them. It's quite annoying. So this is going to be metal film again, or it should be. Yes. And that raw I was saying before about a kilo ohm, it was half a K, not a K. I chose it to be half a K. 560, so that's going to go... You know what, I'm going to pause the video, stare at this and work it out off camera because I honestly, I can't tell what the hell is going on. I know I put an option to go straight to ground with the 560 ohm resistor or to the feedback network, but how I've implemented all of that here, yeah, your guess is as good as mine. I've got 560 ohm resistor and 1000 mic cap that goes to ground. Now, I'm pretty sure that's what this is for here. So I think the resistor goes there and the cap goes there. And then the 22 picofarad poly cap, polystyrene, and the 15k resistor. I'm gonna have to do some thinking. I think that goes there too. And then there's also a 15k resistor that is, God, what have I done? I've drawn something else wrong on here too. Yeah, I'm going to have to pause the video because I'd be lying if I said I wasn't confused. Alright, even after staring at my schematic, I still can't work out what's going on. I'm just going to go bit by bit and try and work it out as I go. Starting with the 560 ohm resistor because that's the next logical part. I believe it goes here. Ouch. Alright. Might as well put the other two on whilst I'm at it. I'm going to have to stop this video soon because although my stomach was feeling bad, that's gone away and it's feeling better now, but this video is getting quite long. You guys would be surprised how long it takes me to build stuff, you know what I mean? I usually do a little bit of work and then come and show you guys or talk about it or do a bit of work on camera and then do a bit off camera. You'd be amazed at how many hours goes into some of the stuff I do. It ain't easy being cheesy. Alright, now those are in, I can try and visualise this a bit more. So, for reference, that 560 ohm resistor there goes to either ground or to the feedback network. That's what this is here. So this little double-ended trace is just to put the other end of the resistor there and then put ground there. So you can ignore that. We need an R and a C over an R. So if I put oh God, this is confusing, I tell you. I think my 15k resistor goes here. I think. And then my R and C goes there. But the other R and C, yes. Wait, what? Oh, jeez. Yeah, I'd be lying if I said I wasn't confused. Oh, I see. The resistor goes there. The capacitor goes there. R, C, R, C, R. Why have I got a pad there? Huh. That's weird. I don't even know. Well, I think I can see how this works. I'm not missing anything, am I? There's an R and a C over an R. And there's an R and a C to ground. And the rest of the network's here. Oops. Okay. Well, I'm going to start building up the R and C network. Doesn't matter if I've run a little bit of an extra pad or trace and it's left open. There could be something I'm missing because I did design this board for research, you know, like to make changes and do tests and all that sort of stuff. So there's a possibility I'm just forgetting something and it's actually a provisionment to install something at a later date. I'm not remembering it now. I should have taken more notes. I think I'll just get one of these little sections sorted out and then I can copy the others off of the one that I've sorted. I'm going to go there for the C. Cool. Yep. Happy with that. I need 22 picofarads, 10k, 15k resistors that I just got. Where did I put them? Over here. So this is what I'm thinking. So that's my R and C, and then if I put an R across there, still have no clue why I've got an extra pad there. Incidentally, the R is supposed to be 15K as well, but I should have that here. Yep, I do. Just got to check my phone. I'm waiting for a phone call. Alright, I've got to go in a sec. I'm just going to get this one R on so we can all visualise. Well, that was weird. An unusually stiff bit of copper. Never had that happen before. I wish I had had my hands further under here on camera. I went to bend the resistor leg and it bent really weird. There was a stiff section, basically speaking. These are proper copper legged resistors, not steel legged ones, so it's weird because it's sort of bent as if it was steel, but it's not. It's got quite a thick lead actually. It's good quality. Alright, I'm going to drop this in. Okay. Alright, I ended up getting all of this laid out off camera. I was on the phone for a while to my missus and I was just working in the background. So I've got the compensation and feedback networks all installed on both boards. There was something I wanted to talk about with the compensation. I can't remember. Oh, right, yeah. So the high frequency bypass RNC that goes over the feedback resistor is set at 480 kilohertz. The RNC to ground is 0.2 something of a hertz. The input RNC is less than that, 0.16 of a hertz, something like that. What else? I think that's all I wanted to say. The compensation caps. Now that's something that I am going to do a bit of experimenting with. I am quite curious as to how that's supposed to work. I've seen a lot of two-pole compensation schemes in different amp designs, and I've seen some where the second cap is bigger than the first cap, others where the first cap is bigger than the second cap in capacitance. I'm not actually sure why that is. I am quite confused there. That's actually something that I'm up to researching now. So I've got a bit of learning to do there. I would imagine based on the way that they're connected, so this capacitor is on the base of the first transistor. The second capacitor is on the collector of the second transistor. So I would imagine that, well, I would have thought that the smaller capacitor would go on the first one, but that is how it's shown on quite a few schematics that I've seen. So I've just gone with those values for starting values, but after testing and doing more research, that might change. So that's something else that I want to point out. This is the reason why I haven't done the final schematic yet. It's not that I've got to make it neat, it's that I've got to make sure it's correct and neat before I show you guys. So yeah. Anyway, moving on. I've probably done about half the board and this video is probably quite long. I'll leave this video off here. Yeah, I'll leave this video off here. And in the next video, because I've still got all of this to fit. There's a lot there. And then after that's fitted, these boards have got to go on the side like this and then get wired over. So yeah, I'll leave that for another video. Alright, well, thanks everyone for watching. And if you like what you're watching, give me a like please and a sub. And I'll see you all soon. Bye.